Okay, buddy, welcome back. Let's get right to it. So we're trying on another one of these frame problems because they're not the easiest ones in the world, but they can also get us a whole bunch of topics right at once. Now, for any of these problems, the first step is usually define your reaction forces. Now, this problem is specifically focusing on point B. I'm going to ignore that and just do every single point for you so you can see all the forces and how we calculate it, because you'll get a lot more out of that. Takes longer, but we can do it. It's not going to be too bad. Now, you get three equations for every free body diagram you draw. This one right here is a roller, which means it only has a force perpendicular to the surface that it's rolling on. It's a horizontal surface, so perpendicular to that would simply be up, which is vertical. So I've got AY right there. This is a pin over here, which means I have an EY as well as an EX. Okay. We've got that. That looks pretty good. So now let's write out our three equations. We're going to have some of the forces in the X direction, some of the forces in the Y, and then some of the moments about a point we will choose in just a minute. Let's do some of the forces in the X direction first. So that's going to be equal to 0, and it's equal to, well, we only have one X force, one horizontal force, so that means it's equal to EX. And that already solves itself. EX is simply equal to 0. And just make it easier myself, I'm going to go ahead and delete that guy. Gone. No longer exists. Okay. Now let's do some of the forces in the Y direction. So that's also equal to 0. It's equal to all the stuff going up first, which is AY and EY. And then all the stuff going down, which is 2,000. So what I get is that AY plus EY is equal to 2,000. We can't solve that one yet, so let's do some moments. Now, as I always say, pick a point that has unknowns. So I'm going to do it around point A. I could have done around point E. That would have worked out just fine. It's going to be equal to 0. Now I'm going to look at each force. 2,000 and EY. And once again, I'm going to do this whole box method because, one, I like it a lot. It works well for many students. If it doesn't work well for you, then you need to find a way that does work well for you. I've shown some other ways too. You can use what I call this just like the point and turn method. So I take a point, I draw a line from where I'm taking the moment, and then I turn in the direction of the force. That tells you if it's clockwise or counterclockwise. That one turned clockwise, so it's clockwise. And then you get to decide is clockwise positive or is clockwise negative. You can determine that. This method, though, just does all that for you. You don't have to guess about which one's positive or negative. It'll just always make counterclockwise to be positive. Okay, so we're doing that 2,000 pound force first. Its distance in the X direction is, let's see here. Ooh, we're going to have to do some detective work here. It won't be too bad. So what we see is that it goes up 6 over a distance of 8. And so if it's going to go 6 in a distance of 8, then how much is it going to go in a distance of 4? Well, I can tell you. So 6, that's the run. Sorry, 8 over 6, that's the slope. It's going to be equal to, make sure I did this right, y over x. Okay, no negative sign there. That's just, oh, sorry, that's part of the picture. I can't get rid of that. There you go. And now I know what my y is. It's 4, because that's how high up this is. So 8 over 6 is equal to 4 over x. X comes out to equal 3. So this distance is 3, and it goes 2 more, which means it has an x distance of 5. The y distance we already calculated as 4. And that's looking good. Now let's look at forces here. So force in the x direction is 0. Force in the y direction is negative 2,000. So AD minus BC. Remember, this is A, that's B, that's C, that's D. AD minus BC is going to be equal to negative 10,000. And the BC is going to be 0, so it doesn't really do anything. Okay, so I got one of my moments, which is equal to negative 10,000. Now I've got to do EY. So distance in the x direction is going to be 12. Distance in the y is 0 for that one. That's pretty easy. Force in the x direction is 0. Force in the y is just EY. You can use variable names here too. It's completely fine. AD minus BC is what equal to 12 EY. So the sign is taken care of for me. I don't have to worry about that. It's all good. Just remember that left is negative and down is negative when you're doing this. Okay, I can solve for this because there's only one unknown, and so let's go ahead and do that. So EY is going to be equal to 10,000 divided by 12, which definitely in my head, definitely not using a calculator right now, I get 833.3. And then I can solve this one too. So AY plus 833.3 is equal to 2,000. So let's figure that out. That comes out to be 1166.7. Okay, so we've got a few of our forces. Now we've got all of our reaction forces for this particular section. Everything we can do for it. Now we want that point B, but I'm going to end up getting all of the forces because I choose to. I can do what I want. I'm your teacher. And so to get all those forces, I need another free body diagram. I can't use the same one anymore. So for frames, what you do is you pick out any individual member and you can use that to make a new free body diagram. So I'm going to pick that member from B to D. I'm going to go ahead and draw it. It looks like this. I'm going to label the thing. So this is B over here. This is D. I'm going to apply my reaction forces. Any place you get rid of a pin, which is what's holding it all together, you put a force in the Y direction and a force in the X direction. I always draw those initially for my first free body diagram in the positive direction. Likely some of these are in the negative direction, but you'll get a negative number and that'll tell you everything's fine. So I have BY, BX, DY, and DX. Okay, and I have this 2,000 pound force, which is 2 from here. If you're wondering how long is this thing, it's 6. I'm just going to go ahead and let you know that it's 6 long. How do I know that? It's halfway up. So that distance right there will be 4. Okay, now I've got 4 unknowns, which means I can't solve all of this yet. But I get 3 equations, which means I can probably solve for 3 of them or get close to solving for 3 of them. So let's do those equations now. So sum of the forces in the X direction is equal to 0. And it's going to be equal to, what did I do right here? That's not dx. I reversed it, I'm sorry. That's dx, that's dy. There we go. Keeping my labels. Okay, so I've got 2 forces in the x direction. It's bx plus dx. And I can't do anything with those because I don't know enough yet. So let's just move on. We'll ignore those for now. So the forces in the y direction, I get that's equal to by plus dy minus 2,000. Okay. Can't solve that one either. My goodness, this is terrible. So finally, sum of the moments. What point am I going to do? I'm going to do point B because I got some unknowns there. You're like, but we want to know everything about point B. We do, but I'm going to get everything. I'm going to solve for everything in this one. Because that way, you get a whole lot of experience in this kind of problem. So some of the moments around point B. So I've got point D and this point that have forces, and I'll do my little box method for both of those. So first the 2,000 pound force. R, F, what R stands for, that's what I use for distance, X and Y. Okay, so my distance in the X direction is 2, distance in the Y is 0. Force in the X direction at that point is 0, and force in the Y direction is negative 2,000. AD minus BC is going to be equal to negative 4,000. Okay, that's one of them. Now let's do that last point and see what we get there. R and F, X, Y, there we go. So my distance in the X direction is going to be 6. Distance in the Y direction is 0. Force in the X direction is going to be dx. Force in the Y direction is dy. So long as they're, both, one's perpendicular, so one is vertical and one is horizontal, you can just put them both in there. If you get like some diagonal ones in here too, then things get wonky. You'll probably need to break it up and do a separate box for that one. Now we do the whole AD minus BC thing again. So let's do that. So AD, that's 6 dy minus BC, that's 0 times dx, that's just 0. So I get 6 dy. So I can solve that. 6 dy is equal to 4,000. And what is that? Oop, I nearly dropped my phone. Woo! I don't want to drop my phone. Okay, so that's 4,000 divided by 6. And I get that dy is equal to 666.6. Okay, now I'm going to use that right there to solve this equation. So by plus 666.6 is equal to 2,000. And so that means that by is going to be equal to 1333.3. Okay, so I'm getting some of my forces here. I still can't solve for bx or dx, which means I need yet another free body diagram. And this is going to bring us to a really important point. So I'm going to draw this member now. Member CDE. Okay, it looks like this. And here's where you have to be really, really careful. Now, these two members are connected like that one we just drew, something like that. And that's great, they were connected. But the forces where they're connected, that's where things get wonky. Because you've already drawn dy and dx once, you're like, okay, I'm going to draw them the same way. You can't. If you draw a second member that has the same forces in it, so like there's point D in this guy too, so this is D right here. That's supposed to be black. This is D right here in the middle. And I've got point E at the bottom. And I've got point C at the top. So I still got a point D in this one. I don't have a point B, don't have any other ones. I still have a point D. If you've already drawn your forces once, you have to draw them in the opposite direction. Okay, the opposite direction. You have to. If you don't, everything goes horribly wrong. As a note, whatever number I got before, it is still that same number. It doesn't change sign. It's just now pointing in the opposite direction. Okay, so let's draw my other forces. I have EY down here at the bottom, which I actually already know. So that's 833.3. And I have a CY and a CX. And now I'm going to need some distances. So let's go ahead and put those in. So boop, in this direction that's 3 and 3. And in this direction, boop, boop, it's 4 and 4. I'm going to need that because it's going to make things a lot easier for myself. Now, we've done that. The hardest part was just remembering to change the direction of your arrows. Everything else is going to go really, really easily now. So let's write out our three equations again, because every single free body diagram gets these. Some of the forces in the X, some of the forces in the Y, some of the moments around a point I'm going to choose. So I will do some of the forces in the X first. I get CX minus DX is equal to 0. So, well, CX is equal to DX. Can't solve it, rants. Let's do some of the forces in the Y direction. I have CY going up plus 833.3. I have 666.6 going down. That's all equal to 0. And so what do I get? 833.3, 666.6 minus 833.3. This gives me a negative number. It's also one of the few times this has happened while I've been doing problems with you. And just as a note, if I get a negative number, it means I drew my arrow in the wrong direction. So I can either flip that arrow or I can leave it. It just depends on what I want to do. I'm just going to leave it for now and say, okay, CY is equal to negative 166.7. Now I'm going to take the sum of the moments. I could take it about point C, but it's kind of pointless because I already know what dx, actually I don't know what dx is. Sure, we'll take some moments around point C. That seems like a decent place. Okay, and so I'm going to do each point. I'm going to do my little box method, and I will get those moments taken care of. So let's set it up, everybody. RF xy are f x, y. Okay. So with that being said, for point D, I'll do that one first. The distance in the x direction is 3. Distance in the y is -4. Down is negative, left is negative. Force in the x direction is equal to negative dx. Force in the y is negative 666.6. Now you notice neither of these is 0. So be very careful as you write it out. It will all work out fine so long as you do. And I'm going to move this equation down here just to make it a little bit easier to see. I kind of put that too close. So I get AD minus BC, so 3 times negative 666.6. That's equal to, close enough to negative 2,000. I'm going to make it negative 2,000. Okay. And that's going to be minus BC. And that's negative times a negative, so it's still going to be negative. So minus 4 dx. Okay. Now we're not done yet. We've got a second one we got to take care of. That's that point E. So distance in the x direction is going to be 8. Distance in the, distance in the x direction is going to be 6. Distance in the y is -8 because we're going all the way down now. Force in the x direction is 0. Force in the y is 833.3. So we do whole AD minus BC thing again, and so I have, let's see here, 6 times 833.3, which is, that's 5,000. I'm just going to go with 5,000 plus 5,000. Okay, so with this, I can say that, let's see, can I do math? Yes, that's all equal to 0. So 4 dx is equal to 3,000, so long as I did my sign right, I did. And so therefore dx would be equal to 750. Okay, now with this, we have enough, I believe, to solve everything. We know that cx is equal to dx, that's going to be equal to 750 as well. And if we know dx, we can go all the way back over here and solve for bx, because bx is equal to negative dx. So let's see, yes, bx be equal to negative 750. And with that, we have absolutely all of our values for this entire free body diagram, for this entire problem set up. What you can see here is we're just always breaking it into these separate free body diagrams. We get 3 equations each time, and by using those, we can solve for everything. Now, thank you all for listening. I'll see you all next time. Bye-bye.